Assalamu alaikum guys. We have this question another question in bending, in which the question is 4.17, and the question is asking for us to find that the question is knowing that for the casting shown the allowable stress is 42 megapascal. So this is my sigma allowable, 42 megapascal, in tension and 105 megapascal in compression. Determine the largest couple M that can be applied. So this is 105 megapascal, sigma allowable tension. Sorry. Compression is equal to 105 megapascal. So the trick in this question is to understand where am I having the compression and where am I having the tension. So if you can look at the diagram that they gave it over here, this is the diagram 4.17. I have an I-beam with a non-symmetric shape, and I'm having a bending in this way. So if I'm bending this I-beam, so this is like the front face, and this is front view. This is the front view. This is the side view. So if I'm bending it this way, I'm gonna have compression in the down. If you can see, let's say it's obvious that the upper part is extending, which means it's having tension, and the lower part is having compression. So the sigma over here will be the compression, and the sigma over here will be on tension. So I've got to find the sigma at this place and sigma at this place and compare it, the tension value with the maximum tension and the compression value with the maximum compression. So this is the basic idea of their question, so let's get to work. The first thing that I have to do is to find the center of gravity. Why do I have to find the center of gravity? Because this is a non-symmetric shape. So whenever I have a non-symmetric shape, the first thing I'm going to find is the center of gravity. Sorry for this horrible diagram, but let's make do. So we have 125, 12, 75, 12, 50, 12. Okay. 125, 12, 75, 12, 12, and 50. So let's say I have A and B and C, and to find the Y, the new center of gravity, I have to make a table, which is the Y bar area, sorry, and the Y bar A, and if you recall the equation, it said to find the new Y bar I would have to sum up all my Y bar into area, divide by the sum of area. So let's say for A, what's my Y bar? Let's say my center is at the middle, or let's say my center is at the bottom over here. So my Y bar would be, the Y bar of A would be over here, right in the middle of this shape, which is, so the distance from, let's say this is my, I'm taking this point as my origin. So the distance from the origin is 6 plus 75 plus 12, which is 93. And for B, it's 12 plus 70 divided by 2. 12 plus 75 divided by 2. No, wait, this is not right. 750 over 2 plus 12 for 9.5. So the value of B is 49.5, and for the part C is at 6. The area of A is 125 and 12. I hope you guys know the equation or the formula to find area of a rectangle. It's base into height, its length into breadth. 125 is the length and breadth is 12, and I get 100. And then I have 75 and 12. $900 and 15, 12. 600. So the y bar into area is 93 by 500. 1500, sorry. 139,500. And the y bar into this one is 49.5. 9.5 into 900, 44,550. 600, 600. 600. So I'm gonna write the summations over here. I don't know the summation of y bar, I need the summation of area and the summation of y bar area. So I have 1500 plus 900, 600, 3000. And 139,500 plus 44,550 plus 3,600. 187,650. And dividing this 2 gives me, divide by 3,000, sorry, 62.55. So my y bar is 62.55 millimeter from the bottom. So basically it's going to be like what? It's going to be somewhere over here. The center of gravity, which is my neutral axis. The distance of this guy from here is 62.5 millimeter. Now, one thing that you should understand is that when my center of gravity is different, or the centroid of the whole shape is different, the eye will also have a little extra part. The eye, which is the moment of inertia, to calculate will have an extra part, and that is going to be, let's say I had I is equal to I of A. Okay, there will be, for each of these shapes, they're gonna have a new I. So I'll have to add each of these shapes new I. Now what is new I of, let's say, A? The new I of A, the new moment of inertia of A, will be the old moment of inertia, which is 1 by 12 ph cubed plus a d square. Similarly for IB, the same thing is IB plus a d square, and for IC is equal to IC plus a d square. Now what the most important thing to understand from here is what is D. Area, I know I can find the area of A, and the moment of inertia of I, or moment of inertia of A, is half into B into H into Q. And B is the base and H is the height. So let's try to understand what's happening over here. So let's say I have this moment of let's say I want to find A. Okay, so let me draw a nicer diagram over here. Okay, and we have established that our center of gravity is somewhere over here, and the center of this shape A is somewhere over here, and the D that we wrote over here is the distance from let's say O to O bar. And as we have said that our distance from here, center of gravity, the new center of gravity, the whole shape, is 62.55 millimeter, which gives this to be 36.45. So 36.45 minus 6, which means 30.45. So the D for A is going to be 30.45 millimeter, and that is what I'm going to use in my equation. And you have to do the same thing for the shape B, and if you think a bit, you can understand that the shape B, no, there's nothing to understand. You'll have to again find the distance of the shape, the center of gravity of the shape B, as compared to the distance of the center of gravity of the whole overall shape. At the same time we do for C. So I'm gonna give a pause. I'm gonna calculate the values of each of these things, and finally we're gonna see the final answer. So I've done the calculation of I, and I have done the calculation using and put all the values over here as I've said before, and I added all these new i's and found the total I at the end to be of this value, the I total. So next what I have to do is to find the sigma, which is the equation of sigma is equal to minus my over I. Now for sigma minus, let's put for compression, my sigma allowable is compression, I have 105 megapascal. So I'm gonna use that to find 105 in 10 to the power 6 megapascal is equal to minus m into minus 62.55, the distance of the minus 62.55 into over I, which is 3.91 to the power minus 4 minus 3. I'm gonna find the answer over here. Let me put a pause and find the answer. So after doing our calculations, we found that the moment maximum that it can be applied if you use a compression is 6560 Newton meter, and for tension it will be 4505 Newton meter. So the least that satisfies both of them is this one. So this is our maximum moment. Thank you very much for watching. I hope you understood it. If you have any question, please ask in the comment section. Thank you and have a good night.